The part of the sun's atmosphere that becomes visible during solar eclipses is the corona. A picture taken with a personal camera or smartphone will capture a globular corona as shown here. Howard Russell Butler's paintings capture the corona as seen by the naked eye. The goal of scientific investigation of the corona is to determine the spatial distribution of the white light brightness. Why are the distributions we photograph different from what we see? Although white light images seem to display the distribution of brightness, the true distribution can only be defined by quantitative measurements. One quantitative representation is isophotes, contours along which brightness is constant, like the elevation lines on a map. By relating images to isophotes, we can determine whether they represent the true distribution. The creation of an isophote provides a tool for measuring the distribution of brightness in images made at different exposures. When less light is captured, the image shrinks, but its shape remains consistent with the isophote. This validates the globular corona as depicting the true distribution. Quantitative isophotes also reveal the steep falloff in brightness with radial distance. Just one solar radius from the sun's surface, brightness drops by more than a factor of 100. The specialized Newkirk camera of the High Altitude Observatory photographs the corona through a radially graded filter. It suppresses the bright inner corona in order to show the fainter streamers of the outer corona in a single photograph. Because the structures revealed in processed images show little coincidence with the isophotes, they are artifacts. The striking resemblance between Butler's paintings and the processed images tells us that perception of the eye and brain copes with the extreme range of brightness in similar fashion as the Newkirk camera. Compensating for the steep brightness falloff produces artifacts in imaging and illusion in perception. While both do not represent the true distribution, the processed image introduces an additional artifact, the so-called coronal holes, dark coronal regions at the base of the corona found predominantly at the sun's poles. But these same coronal holes are absent from the illusion captured by Butler's paintings. Coronal holes appear in processed images because of inadequate brightness detection. When brightness is increased, the coronal holes disappear to resemble Butler's paintings. That white light coronal holes are artifacts is significant because they have been interpreted as a key source of the solar wind, the plasma of charged particles streaming from the sun at high speed and filling space. The true source of the solar wind can only be defined by quantitative measurements of brightness. If you are lucky enough to see the 2017 solar eclipse, your pictures will show a globular corona. Do not be disappointed. In terms of brightness distribution, you have truth on your side.